Hello and welcome. In this video, we're going to be discussing how to solve a word problem. So let's actually begin with this problem. If I just read it through, suppose type A coffee costs $5.40 per pound and type B coffee costs $4.30 per pound. This month, someone purchased a 154-pound mixture of type A and type B coffee for $766.70. How many pounds of type B coffee were purchased? So there's a lot going on in this problem, but one of the things I want to point you towards is the fact that we have several different numbers along with several different kinds of units. So one of the numbers that we see is we've got $5.40 per pound. Another kind of number we have is just pounds. We've got 154 pounds. And then a third type of number that we have is just dollars. So the question is, how do those three kinds of units relate to each other? How do dollars per pound, pounds, and dollars relate to each other? Well, I like to begin this with just a pretend situation. So let's pretend that you walked in the store and you saw that your favorite chocolate was $5 per pound. And you decided, you were so excited that you were going to buy 4 pounds of this chocolate. How could we figure out how much you're actually going to pay at the register? Well, we know that for every pound you buy, it's $5, and you're buying 4 pounds. So one way we could figure out your total cost is if I take the dollars per pound times the number of pounds that you're buying. So in this case, if I take 5 times 4, that's going to tell me how many dollars we're paying. So notice that we've just come up with a relationship that relates our three kinds of units. If I take dollars per pound times the number of pounds, that gives me the number of dollars. So the first step when we're doing a word problem like this is I want to come up with an equation that relates our three units together. So in this case, it's going to be dollars per pound times the number of pounds equals the number of dollars. Okay. So the equation that we're going to use is dollars per pound times the number of pounds equals the number of dollars. Okay, the second thing I want you to notice is that there's two different types of coffee here. So when we're calculating total cost over here, we're using our formula, we should have kind of an entry for both type A and type B. So what I'm going to do is I'm going to create a table to organize our information. So on the left-hand side, I'm going to have type A, coffee, type B, coffee, and then I'm also going to have a row for any information that pertains to both type A and type B. So what I'm going to do is just make a table out of what I have. Okay, so now if I go back and try to fill things in, well, what I know about type A is that it's $5.40 per pound, and type B is $4.30 per pound. So I can fill both of those in. So the cost per pound for type A is $5.40. Type B is $4.30. Okay, they also tell me, another number they give me is they say that there's a 154-pound mixture. So if it's a 154-pound mixture, that's really not for just A, it's not really for just B, it's really for the combined. So the 154 pounds is going to go under my pounds column, and it's really the combined. The only other number I see that they give me is this $766.70. And that looks like it's the cost of purchasing that mixture. So the $766.70 is going to go under my dollars column, and it's going to go under the combined row. So it's going to go over here. So it's $766.70. Okay, well, what about my other entries? Well, what were we looking for? What we were looking for was how many pounds of type B coffee were purchased. Right now, I don't know that information. That would go right here. Since I don't know it, I'm going to call that X. Okay, what about type A? Well, I don't know that one either, but I would like to, if at all possible, since I'm really not looking for the number of pounds of type A coffee, I'd like to not to have to introduce a second variable. So if we look at the information that we have in this column, here's what I know. I know that there are 154 pounds of coffee purchased total. Of that 154 pounds, X pounds are type B. So let's say, for example, we know that 50 of those 154 pounds are type B. How could I write an expression for the number of pounds of type A coffee? Well, if I knew that 50 pounds were type B, A would just be 154 minus the 50. Or in other words, A is going to be 154 minus the number of pounds of type B coffee. Okay, now what I want to do is write an expression for how much I'm paying for each type of coffee separately. So if we look at type B coffee first, I'm paying $4.30 per pound and I'm buying X pounds. So that means at the register I'm going to be paying $4.30 times whatever X is. What about for type A? Well, I'm going to be paying $5.40 times 154 minus X. The number of pounds that I'm buying. So let's see what we got. In this last row, I know that overall I'm going to be paying $766.70. Where does that come from? Well, that $766.70 is going to be the amount of money I'm paying for type A coffee plus the amount of money I'm paying for type B coffee. So if I take these two guys and add them together, that should equal my total amount. So now I've got my equation. It looks like this. $5.40 times 154 minus X plus 430X equals 766.70. So from here, I just want to solve this equation. So first step is let's distribute. So 540 times 154 is 831.60 minus 5.40x plus 4.30x equals 766.70. If we combine our two x terms, we've got 831.60, and then we've got minus 110x equals 766.70. Subtract 831.60 from both sides. And that's going to give us negative 110x on the left-hand side. On the right-hand side, we've got negative 64.9. Divide both sides by negative 110. And x equals 59. And remember, because of the way that we labeled our table, x was exactly what we were looking for. That represented the number of pounds of type B coffee, which is precisely what we were interested in finding. So x equals 59 is our final answer.